All right, let's get started going over this review. Number one, simply find n. Hopefully you noticed this is a 30, 60, 90 triangle, and even though the 30 is not written, you have 60 there, so you have no other choice for that to be 30. In the pattern, you have x, or the formula, x square root of 3, 2x. Now eventually you want to find n, so you have to find what 2 times the x is. The only side you have a value for is right here, 10 square root of 3. So you're going to take the formula, n times x times the square root of 3, set it equal to 10 square root of 3, and solve that. Now, this is not the complicated one because if you divide by the square root of 3, these cancel and these cancel, and you're literally left with x is 10. Now, don't forget you're looking for n, and n is 2x, so this is 2 times 10, and your final answer is n is 20. All right. Number 2, find the length of the diagonals of a square whose side length is 9. So just draw yourself a general square, right? Diagonal, you want to find its length, and the side length of each side is 9. And it's a square, so obviously they're all the same. You technically have two choices here. Okay, there is no reason you cannot do n9 squared plus 9 squared equals c squared. The diagonal is the c, right? Pythagorean theorem will work. However, it is easier if you understand the formula. This is a 45, 45, 90. When you take a square and cut it diagonally, that makes x square root of 2. So you can solve this problem out, and when you do that, you're going to get, by Pythagorean theorem, you're going to probably wind up at c squared equals 162. You divide that, or you square root it, of course, but it breaks up into 81 times 2, and the square root of 81 is 9. Square root of 2, you can do that. Or if you look at the formula, x is 9, you literally just put 9 in front of the square root of 2. Again, both will give you the answer. It's just which you know better and understand. So, the better you understand the special right triangles, the easier it makes a lot of these problems. But there's an example where either one could work. Number 3, a 24-foot ladder is leaning against a building. The foot of the ladder makes a 60-degree angle with the ground. So, obviously, we're dealing with right triangles. You're going to get something like this. Okay, here's your ladder, 24 feet. But it says the foot of the ladder makes a 60-degree angle with the ground. So right here, 60 degrees. How far is the ladder from the base of the building? So we're looking for this right here. Now, if that is 60 here, this is going to be 30. And even though my drawing's a little bit off, by your formula, that's x, 2x, x square root of 3. Now again, anytime you have this, you have the formula, you set it equal to the value there. So it's 2x there, 24 is what they give you. 2 times what is 24? Divide by 2, x is 12. You want this value here, and that is what that is, so that is just your answer. X equals 12. Number 4, the length of the hypotenuse of an isosceles right triangle is 10 inches. So you have an isosceles right triangle. That means two sides are congruent. That makes it a 45, 45, 90 right triangle. Hypotenuse is 10. Again, formula. You'll have the formula chart tomorrow. X square root of 2. This one is a little complicated if you don't know the formula. The shortcut, we'll do the shortcut in a second. But again, take the formula, set it equal to the value they give you on the triangle. You're going to divide by the square root of 2. Unlike an earlier problem, this cancels out, but there's no canceling out yet on this side. Remember, cannot keep a denominator with a square root there. You're going to multiply this fraction, because we need to rewrite it, with the square root of 2 over the square root of 2. That represents 1, a number over itself, but it's going to help us clear out the denominator. On the top, you get 10 square root of 2 On the bottom, they combine. 2 times 2 is 4. The square root of 4 is 2. Now you no longer have a denominator on the bottom. You divide 5 square root of 2. Last problem, find the altitude of an equilateral triangle whose sides are 8 centimeters. So you have an equilateral triangle as best you can. 8, 8, 8. Altitude, line that goes from the angle straight down 90 degrees. You've cut this into 2 little 4/4s, and because it was equilateral, it was a 60-degree angle in every corner. You have created 2 30, 60, 90s because you cut this in half up here. So again, you come to this point where you can do 2 things. You can do Pythagorean theorem because we're looking for that for the altitude right there. You can do 4 squared plus b squared equals 8 squared. You can solve this with Pythagorean theorem. 64 minus 16. 64 minus 16 is 48. You're going to square root that. That breaks up into 16 and 3, which gives you a final answer of 4 square root of 3. Sorry, let me try that again. 4 square root of 3. Now, as a formula for Pythagorean theorem, it's x, 2x, and that's x squared root of 3. Now look, you already have the x. The x is 4. So if the altitude is simply x times the square root of 3 and your x is 4, again, you could just simply write 4 square root of 3 from the formula. Both methods work. Pythagorean theorem or special right triangles, it just depends on you, on what you are comfortable with. All right, number 6. A kite string is 150 feet long from the kite to the ground. The string makes 45-degree angle with the ground. About how high off the ground is the kite? So first of all, we're talking kite string. This is 150 feet. Make sure you place it in the right area, right? It's not the height, that's the string. They want to know how high the kite is, so if you draw a line to represent the height, now you have a right triangle, specifically a 45, 45, 90 right triangle. So by the pattern, this would be x squared root of 2, x, x. Now, let's do this one by the shortcut, because we did a previous problem just now where we did the whole multiplying by the square root of 2 over the square root of 2, and that process. The shortcut should make this easier. If your hypotenuse in a 45, 45, 90 right triangle is a whole number. Now, notice, the pattern shows x squared root of 2, but the answer is a whole number. That means that your answer is going to have a square root in it. So x times the square root of 2 equals 150. Your answer is going to be something square root of 2. To find the number that goes in front, simply divide the length of the hypotenuse by 2, or whatever number is in the square root, because on the 30, 60, 90, you can do the same thing, but that's square root of 3. But this one is 2, so divided by 2. 150 divided by 2, 75. That represents x, both the height and the length on the ground. Okay, that's the shortcut when this is a whole number. All right. Number 7, looks similar, but is not, to problem number 3. Let me clear a few things off the screen here a second. So this time you have a 24-foot ladder leaning against the side of a house. But they tell you specifically that it's 6 feet on the bottom from ground to bottom of the ladder. They want to know how high up the house is the top of the ladder. No angle measurements mentioned. You have to do Pythagorean theorem here. A squared plus b squared equals c squared. So this one's going to require subtraction. 24 squared minus 6 squared is 540. break it down, when you square root, 540 is going to be 36 and 15. Right, so you're going to get b equals square root of 36 times square root of 15. Square root of 36 is 6. Square root of 15 stays under the sign, and that is your answer. All right, last problem on this page. The bottom of a loading ramp is 15 feet from the side of a loading dock. The length of the ramp is 17 feet. What is the height? So, little word problem, but just a really simple Pythagorean theorem. A squared plus b squared equals c squared. Again, a and b can be mixed up, but that longest side has to be c. Has to be across from the 90-degree angle. Again, you're going to subtract. You're going to get 17 squared minus 15 squared. X squared equals 289 minus 225, which is 64. X is 8. And that's it. So that concludes the front page. Check the next video for the back page, and hope this helps. Be ready for tomorrow.